Welcome to AI DevHub Digest. This is our deep dive for the week, and the sources really paint a picture of, well, a clash of giants. We're seeing two major themes converging.
Yeah, absolutely.
First, there's this relentless acceleration, almost shocking sometimes, with these frontier models. And second, a really fundamental overhaul happening in the AI developer ecosystem. Think new SDKs, context management. It's a lot.
It's absolutely right. And the pace, it isn't just the models getting smarter, it's the tooling around them getting way more complex fast. So for you, the developer listening, this landscape is, well, it's full of opportunity, sure, but also packed with potential cost traps. You really need to watch your budget.
Right.
So our mission today really is to cut through this massive flood of releases. You've got trillion parameter open models on one side, critical context breakthroughs on the other, and focus specifically on what hits your workflow right now, what impacts your development process, and maybe even more critically, your bottom line. We're tracking this crucial shift. It's not just about who has the most raw power anymore. It's about power you can actually use, power that's efficient, and frankly, power you can afford.
Okay, let's unpack this immediately then. We kind of have to start with the company that, well, keeps setting the bar even if the price sometimes feels like it's on another planet.
Yeah.
We're diving into part one, the frontier model landscape, power, price, and competition. And naturally, kicking off with OpenAI, their latest moves look like targeted specialization and just peak performance, almost regardless of cost.
It is. It's a very calculated dual strategy. Seems designed to capture, two pretty different parts of the market.
Okay.
So on one hand, they dropped GPT-5 Codex. Now, this is a version of GPT-5 specifically tuned, really optimized for development tasks.
Right, focused on coding.
Exactly. The main takeaway here is that specialization. They fine-tuned it on just vast amounts of code, debugging sessions, execution traces, all that stuff. And the result, it demonstrably outperforms the general GPT-5 parent model on standard programming benchmarks.
So it's genuinely better for developers than the base GPT-5.
For coding tasks, yeah, the benchmarks show that. This is basically their reliable, high-end coding workhorse. And it's out now, available via API, same pricing as the standard GPT-5, interestingly. And it's already integrated into the Codex Assistant, too. We're already hearing reports, actually, developers who are maybe using specialized tools like Cursor. Some are switching their back-end model to Codex just for that extra performance boost on, say, complex refactoring or tricky debugging jobs.
Interesting. Okay, so that's the specialized workhorse. But then there's the other side of that dual strategy.
Right. Then we pivot from the workhorse to, let's call it the Apex Predator.
Yeah.
GPT-5 Pro, the new performance Apex.
And this is the top dog.
This is pretty unequivocally OpenAI's most powerful model to date. And if you look at raw capability, especially programming aptitude, it currently stands as, well, arguably the strongest overall programming model on the market, period.
Wow. Okay. But strongest usually comes with a catch, right?
It's the absolute high watermark for current LLM tech, yeah?
Right.
But the price tag, it's staggering, really staggering. The key spec, technically, is the massive 400K token context window.
400K tokens, that's huge.
It's incredible, yeah.
No.
Think large-scale enterprise projects, understanding architecture across massive repositories, handling really deeply nested code bases. It's built for that. However,
here it comes.
The fixed pricing for this premium model, it just redefines expensive. We're talking $15 per million input tokens. Okay, but wait for it. An astronomical $120 per million output tokens.
$120 per million output tokens. Let's just pause on that. For perspective, that's, what, 10, maybe 20 times higher than a lot of the other big players we're going to talk about today, especially the ones focused on efficiency.
Exactly. 10 to 20 times higher. The implications are pretty profound. This model, realistically, is reserved for the absolute highest value tasks, the ones you can't easily repeat, where the cost of getting it wrong is massive.
Like finance, maybe? Or defense?
Precisely. Regulated industries, finance, defense, maybe projects dealing with super sensitive IP, where speed and absolute dead-on accuracy just dwarfs any financial concerns. You are paying a fixed, massive premium for that absolute peak performance ceiling.
So it's niche.
For probably 99% of development tasks, that marginal performance gain you might get over the next best model. It just doesn't justify paying 10 times more.
Wow.
OpenAI knows this. They're deliberately creating a niche product for the absolute top tier, knowing full well most developers will happily stick with the cheaper GPT-5 or the specialized Codex version.
It's a clever strategy, though. Use Pro to set the brand perception, establish that ceiling, but make the real money selling the specialized Codex model for the volume work.
It's masterful strategically, but the competition, they're betting hard that developers, especially at scale, are going to seriously balk at that Pro price point.
Makes sense. So who's stepping up in that high-end space?
Exactly. And the most direct competition, especially in that high-end large context arena, is coming from Anthropic and Google. Anthropic, particularly, seems to be trying to thread a needle. They want the power, something close to GPT-5 Pro, but with the affordability of more of a general workhorse model. And their answer is Claude Sonnet 4.5.
And this one's also tuned for development.
Highly optimized for development tasks, yes, which makes it a very, very serious contender.
And the rankings back that up, right? I saw it's pretty high.
They do. Sonnet 4.5 currently sits as the #2 coding model globally. It's only trailing GPT-5 Pro and, interestingly, an internal Google model called Gemini 2.5 Pro DeepThink.
DeepThink. Haven't heard much about that one.
Right, because it's still exclusive to Google's Ultra subscribers, not generally available yet. But Sonnet 4.5 is available, and it's a proven performer. Code generation, refactoring, logical reasoning, it's strong.
Now, Anthropic's also playing the context window game, competing on size there, too, but I heard there's a catch, a budget thing developers need to know.
There is. They absolutely offer the bragging rights of scale. Sonnet 4.5 boasts a really impressive 1 million token context window. Massive.
1 million tokens.
Yeah. However, the fine print is absolutely critical if you're watching your budget. The price per token increases significantly. Sometimes it even triples once you go past the first 200,000 tokens.
Okay. So the big number isn't the cheap number.
Precisely. This pricing structure, it's strategic. It basically means, yeah, you can technically stuff your entire project folder into the model for analysis. But if you do that frequently, your cost structure completely changes. It can quickly wipe out any cost savings you thought you were getting compared to using a model with a smaller but cheaper context window.
So it's a great marketing number, 1 million tokens, but maybe less practical for cost-sensitive, high-volume use.
That's a fair assessment. It gives you the potential for massive context, but the pricing mechanics kind of nudge you towards more typical, shorter context usage, which is probably more profitable for them anyway. That's sort of the strategic reality of this whole context window war right now.
Interesting. So that's Anthropic. What about Google's approach?
Google seems to have taken a pretty different path with Gemini 2.5 Flash and Flashlight. They appear entirely focused on just improving the existing developer experience and rolling out upgrades without hitting the customer with higher costs.
So quality of life improvements?
Exactly. Their latest update was pretty much a pure win for developers using those models, focused on speed, reliability.
What specifically did they improve?
3 main things, according to the sources. 1, the models are significantly faster now. 2, they're more concise, less waffle, less padding in the outputs, which actually saves you on prompt engineering effort and output token costs.
Nice.
And 3, much better instruction following and just more effective use of tools and multimodality features. But here's the kicker, the crucial detail, especially when you compare it to that GPT-5 Pro price tag.
Let me guess. The price stayed the same.
Exactly. No change in pricing for all these enhanced features. Google is basically signaling, hey, the performance floor for our accessible models keeps rising, but the cost floor, that's staying put. It's a powerful message for developers worried about escalating costs, a real lure for volume customers.
Okay, really different strategies there between OpenAI, Anthropic, and Google. But the competition isn't just in the US, is it? Let's look globally.
Absolutely not. Shifting focus, we need to talk about the closed-source challenger coming strong out of Asia. Alibaba has been pushing hard, demanding global attention.
Right.
The release of Alibaba Qwen 3 Max, that's their flagship closed model, is a pretty big deal. It's officially out of preview now, generally available.
It comes in different flavors.
Yep, base, instruct, and then the really powerful thinking version. And what's fascinating here is that the thinking version, which is designed for really complex reasoning and logic problems, is benchmarking extremely close to the established Western leaders. Think GPT-5, Grok 4. It's right there with them.
Wow, that's fast progress to reach near parity at the top end.
It is. And it means developers globally, including here, really can't afford to ignore these models anymore. They're serious contenders.
And specifically for our audience, the developers, they have a coding-focused version too, right? Qwen 3 Coder. How's that stacking up?
Indeed. And the updated Qwen 3 Coder has truly hit a competitive parity point. It now includes multimodality support, so it can process images alongside code, which is useful for UI generation or diagram understanding.
Okay.
And it's achieved really remarkable results on SW Bench.
Remind us what SW Booch tests.
SW Bench is critical. It's not just about generating boilerplate code. It tests a model's ability to fix real-world, documented software bugs found in actual GitHub repositories. It's about practical debugging and fixing.
And Qwen 3 coders doing well there.
Extremely well. Achieving results on par with top-tier Western models like Claude Opus 4 and the standard GPT-5, that tells you Qwen 3 Coder is production-ready. It's a highly capable debugger and refactorer.
So the big picture message for developers everywhere seems clear. You don't automatically have to default to OpenAI or Anthropic or Google anymore to get state-of-the-art coding help.
That's exactly it. This increased global competition, especially from models that often come with very competitive pricing strategies, puts real, tangible pressure back on the big U.S. players.
Which forces them to differentiate either on sheer power like GPT-5 Pro
Or on price and efficiency. Which brings us perfectly into our next section.
Right. This moves us neatly into part 2. Open source and architecture innovation efficiency is the new power. Because if part 1 felt dominated by brute force and, frankly, eye-watering costs,
Oh, yeah.
part 2 is all about clever engineering and squeezing more performance out of fewer resources, or at least fewer active resources. It feels like the high price of those top-tier models is actively pushing developers towards alternatives.
That's the crucial connection. That cost barrier created by models like GPT-5 Pro doesn't just stop demand. It actively redirects it towards models that prioritize efficiency. And open source is stepping up big time, often using architectural smarts, not just throwing more parameters at the problem.
Okay, so let's talk about some of these new open giants. First up, Ling1T from Inclusion AI. Now, 1T, 1 trillion parameters. That sounds like the exact opposite of efficiency. What's the catch?
The catch is the architecture. It's all about how it uses those parameters. Ling1T is a mixture of experts model, or MoE. This is probably one of the most important architectural trends we've seen in the last year or so.
Okay, explain MoE simply. How does that make a trillion parameters efficient?
Right. So in a standard model like, say, GPT-3, every single piece of input, every token, has to pass through every single layer, every single neuron. It's computationally heavy.
Okay.
In a MoE model, imagine you have lots of smaller, specialized subnetworks inside the big model. These are the experts. Maybe one's great at code, another at math, another at history, and so on.
Got it.
When your prompt comes in, there's a sort of router network up front. Its job is to look at the prompt and say, okay, for this task, I need experts number 3, 7, and 12. And only those few experts get activated and do the work.
Ah, so instead of the whole trillion parameters firing up, only a small fraction does.
Exactly. So Ling1T has a massive 1 trillion parameters total, giving it a huge knowledge base.
Yeah.
But during any specific task, only about 50 billion parameters are actually active. You get the knowledge capacity of the giant, but the speed and, crucially, the cost efficiency closer to a much smaller 50 billion parameter model during inference.
That's clever. Scale without the full cost of scale.
Precisely. And Ling1T leverages this architecture to be incredibly powerful, yet surprisingly efficient. It's specifically designed for those high-value tasks developers need. Coding, math, logic, even front-end generation.
That really is scale efficiency, and it feels like this kind of innovation is helping close the gap between the big closed models and open source.
It absolutely is. And another prime example is Z.AI's GLM 4.6. They're now officially claiming the state-of-the-art crown for open source models.
Okay, what are its specs?
It's a beast, 357 billion parameters, so still very large, but it boasts a competitive 200K token context window. And again, critically, it was trained specifically with programming tasks in mind.
And the performance. Does it really match the closed giants?
Independent benchmarks are showing that, yes, it's matching closed models like Claude Sonnet 4.5 in complex coding performance. This is probably the clearest signal yet that the open source community has crossed a major threshold. You're no longer automatically sacrificing top-tier performance just because you want to use a transparent or self-hostable model.
Yeah.
The gap is closing, maybe even closed in some areas.
That's huge for developers wanting flexibility or control over their stack. But the efficiency gains aren't just limited to these massive MoE models, right? We're seeing optimizations in the mid-range too.
Definitely. Moving into mid-range and efficiency breakthroughs, we're seeing clever optimization techniques that translate directly into significant budget savings for developers using these models.
Like DeepSeek.
Exactly.
Yeah.
Take DeepSeek v3.2x ESP. It's a 695 billion parameter model, so still large, But its entire value proposition is built around efficiency, driven by architectural change.
Uh,
It delivers the same high-level performance as its predecessor, v3.1 Terminus.
okay.
And this is the key part, at half the operational cost.
Half the cost for the same performance. How did they manage that? What's the trick?
The trick is sparse attention.
Sparse attention. Okay, break that down.
So in traditional attention mechanisms, which are core to how transformers work, the model calculates the relationship, the importance between every single token in the input and every other token.
Right, that sounds computationally expensive, especially with long context windows.
It explodes exponentially as the context grows. That's the scaling problem. Sparse attention is a technique that's much more selective. It doesn't calculate attention between all possible pairs. Instead, it tries to intelligently identify and focus only on the most critical, most relevant connections and context elements for the current task.
So it ignores the less important stuff.
Pretty much. It radically reduces the computational workload needed to process the context without significantly sacrificing the ability to handle large amounts of information. And that computation reduction directly translates to lower operational costs for anyone running the model. Half the cost in DeepSeek's case. That's smart engineering delivering real savings.
Definitely. Okay, meanwhile, IBM is also making a play in this mid-range space, but with a specific angle, targeting enterprise adoption.
Yes, the release of the IBM Granite 4.0 family is quite significant, especially for enterprise developers. It's a family of 4 MoE models, they call them H, small, tiny, and micro, specifically designed to hit that sweet spot of reliable mid-range performance.
What are their specs like?
Solid, dependable performance, competitive 128K context window. Nothing earth-shattering, perhaps, but very capable. The crucial element here, though, the thing that makes developers perk up, especially those building commercial tools.
The license.
The license. They're released under the extremely developer-friendly Apache 2.0 license.
Apache 2.0, that is huge. That single detail could make or break a startup idea, right? Avoiding complex proprietary license fees or restrictions.
Absolutely. Apache 2.0 essentially gives you the freedom to use, modify, and distribute the software for pretty much any purpose, including commercial use without hefty fees or restrictive terms. It's exactly what enterprise developers and startups often need. IBM seems to be betting on building an ecosystem and driving adoption through openness rather than locking things down. It's a direct challenge to the proprietary mid-range models out there.
Okay, this brings us to maybe the most intriguing part of the efficiency story, the compact powerhouses. We're now seeing models under 3 billion parameters that are somehow punching way above their weight. This feels like it could shift the whole paradigm.
This trend is arguably one of the most exciting, especially if you're thinking about running models on edge devices in smaller company deployments, or even locally on developer machines. Look at AI21's Jamba 3B.
Jamba 3B. 3 billion parameters. What's special about it?
Well, first, it's reported to be extremely fast. Second, it has a massive 256K token context window, which is kind of nuts for a model that small. And third, like the IBM models, it's also released under that attractive Apache 2.0 license.
Okay, fast, huge context for its size, open license. That's a compelling package. How's the performance?
That's the kicker. Jamba 3B is apparently outperforming much larger mid-range models. Specifically mentioned were Q134B and IBM Granite for Micro on complex reasoning tasks.
Wait, a 3B model outperforming a 4B model on reasoning. How?
It challenges that long-held assumption, doesn't it? That bigger automatically means smarter or better at reasoning. Jamba's performance suggests that maybe its internal architecture, how it's structured, has a higher ratio of reasoning ability per parameter. The overall capacity might be smaller, but it seems to use what it has very efficiently for logic.
Fascinating. And there are others in this lightweight class.
Yep, confirming this trend is Liquid AI's LFM2 2.6B, another strong contender in this hyper-efficient category. It also boasts high benchmark rankings and a respectable 128K context window.
Any downsides to that one?
The only real caveat mentioned is its license. It's described as a semi-open proprietary license, which might give some developers pause compared to the fully open Apache 2.0 options from AI21 or IBM. But performance-wise, it's another clear signal of this fierce drive to pack high intelligence into smaller, more efficient packages.
This whole less is more momentum seems to culminate in a piece of research that sounds, well, almost unbelievable. It really underscores this whole architectural insight theme.
We definitely need to spend a moment on Samsung's TRM, the tiny recursive model. The research paper they published is genuinely astounding. It fundamentally challenges how we even think about training these models.
Okay, what did they do?
They built a 7 billion parameter model. Relatively small by today's standards, right?
Yeah, 7B is practically tiny now.
But here's the jaw dropper. They trained it on only 1,000 examples.
1,000, not million, not billion, just 1,000. That's like nothing. Isn't that like 10,000 times less data than typical LLM training runs?
Exactly, 10,000 times less data.
Yeah.
It's minuscule. And yet, this 7B model, trained on virtually no data, outperformed established models like DeepSeek R1, Gemini 2.5 Pro, and even O3 Mini on rigorous reasoning benchmarks, specifically IRC, AGI 1 and 2.
And those benchmarks test real reasoning, not just memorization.
Correct. They test abstract reasoning, problem solving, generalization, things far beyond just regurgitating training data.
So what does this even mean? Are we finally finding ways to build intelligence through clever architecture, through recursive structures and algorithms, rather than just brute forcing it with petabytes of data and hoping complexity emerges? Is the entire industry's training philosophy maybe inefficient?
It raises precisely that uncomfortable, fundamental question. The research strongly suggests we might just be scratching the surface of discovering new architectures that prioritize efficient reasoning and structured learning over just massive data ingestion. Is it possible that the current model of just scaling up data and parameters indefinitely is simply compensating for architectures that aren't inherently efficient at reasoning?
If you can get top-tier reasoning from a 7B model trained on almost no data, why are we spending billions training trillion-parameter models?
It implies the answer might lie more in the training methodology and the architecture itself, not just the sheer scale of parameters or data. Yeah. It's a profound challenge to the status quo.
And that challenge leads us nicely to another interesting architectural idea, this one from a Polish startup called Pathway. Their paper proposed something called the Dragon Hatchling. Intriguing name.
It is, and their idea focuses on a really critical, still largely unsolved problem in AI temporal generalization. Basically, how do models learn and adapt over time based on ongoing experience?
Right. Models today are mostly trained on a static data set. They don't really learn continuously from interaction.
Exactly. Pathway proposes architectures that are closer to how biological brains work, structures that could allow models to actually learn from real-time experience, not just rely on that fixed pre-training data. The goal is a model that can evolve, adapt, and learn while it's running, based on its interactions and feedback. Imagine persistent, long-running agents that actually get smarter over time. That's transformative.
And that idea of persistent learning agents connects perfectly to where we need to go next, because as the models get smarter, more efficient, maybe even capable of learning, the tools we used to build with them are being radically reshaped.
Absolutely. Let's pivot hard now into part 3, the Developer Toolkit Revolution, SDKs, context, and agents.
And OpenAI's recent Dev Day 2025 seemed less about groundbreaking new models and much more about building out their ecosystem, building the moat, really, through tooling and integration.
That was definitely the feeling. Less about the core model, more about making it indispensable in the developer's workflow.
Starting with direct IDE integration. They launched official Codex CLI plugins for both VS and JetBrains IDEs. That feels like a direct assault on the developer's desktop environment.
Oh, these plugins are a major move because they bring the full power of that specialized GPT-5 Codex model directly into the two most dominant professional development environments. No need to switch windows or use a separate tool.
And are they any good?
The reports suggest they're highly capable, handling complex inline code suggestions, interacting with the integrated terminal, analyzing code across multiple files in a project. Sources said some developers actually switched away from dedicated AI IDEs like Cursor or Anthropic's Claude Code because the official OpenAI plugins were good enough.
How do you access them?
You can run them either via the API, paying per token, or using your standard ChatGPT subscription. And there's a rumor, unconfirmed but strong, that Pro subscribers have virtually no usage limits on these plugins.
Wow. Okay, so OpenAI is embedding itself right into the core development loop, asserting control right where the code gets written.
That's the strategy. And they didn't stop there. They solidified this ecosystem push with a trio of new SDKs designed to expand what developers can build on top of their platform.
Right. The Apps SDK, Agent Builder, and Chat Kit. Let's break those down. Apps SDK first.
Apps SDK is currently in preview. It lets developers build functional, interactive applications that run directly inside the ChatGPT interface. It uses something called the MCP protocol.
Okay, MCP protocol. We've seen that acronym pop up. What exactly is it? Why is it important?
MCP stands for Multi-Context Protocol. Think of it as OpenAI's universal language layer for interaction. It's a standardized way for different components, the core models, agents, these new apps, external tools to exchange structured data, manage complex conversation histories, track context effectively, and crucially.
Let me guess. Handle payments and authentication.
Exactly. It supports user authentication and payments. So the app's SDK uses MCP to essentially transform ChatGPT from just a chat interface into a kind of miniature operating environment. It can run one authenticated, potentially transaction-capable application right there inside your chat session.
That's a significant shift from chatbot to mini OS. Okay, what about Agent Builder?
Agent Builder looks like a direct competitor to existing low-code or no-code workflow automation tools. Think platforms like N8N or Diffy. It's a visual editor.
So drag and drop for building AI workflows.
Pretty much. Its
Yeah.
goal is to lower the barrier for creating complex agentic workflows, letting people chain together API calls, logic steps, tool usage, all without needing deep programming skills. It's about expanding the accessibility of their API functionality.
Makes sense. And the third one, ChatKit.
ChatKit is the integration piece. It's an SDK specifically designed to make it easy for developers to embed ChatGPT functionality, the chat interface, the model access into any website or application they might be building. It's about making OpenAI's tech ubiquitous.
So plugins for the IDE, apps inside ChatGPT, a builder for workflows, and a kit for embedding it anywhere. That's comprehensive ecosystem control.
It is, and they underline this commitment to being a reliable platform by taking the main Codex service officially out of beta.
Ah, Codex goes production. What does that mean practically for developers?
It's the signal that you can now build critical applications relying on Codex as a backend, with higher guarantees of stability and support. Key features mentioned were its ability to stay active for up to 7 hours continuously.
7 hours. Why is that important?
Think long, complex build processes, continuous code monitoring or analysis tasks, maybe long-running simulations or data processing jobs driven by code generation. It needs to stay alive. It also now includes Slack integration for notifications and updates, and a dedicated web admin panel for team subscribers. This all signals that OpenAI sees Codex becoming a core, reliable, long-running engine for enterprise development workflows.
Okay, so while OpenAI is busy building this sort of agent operating system, Anthropic seems focused elsewhere, solving a different core problem.
Yeah, Anthropic's big announcements were less about ecosystem dominance and more about tackling arguably the #1 functional headache with building complex, long-running agents, managing context effectively and giving them memory, dealing with what some people call agentic amnesia.
Right, the problem where agents forget what happened earlier in the conversation or lose track of the overall goal, and the massive token costs associated with stuffing everything into context.
Exactly those problems. And this development, available now with Claude Sonnet 4.5, is potentially a massive functional game changer. They introduced 2 major API updates, context editing and the memory tool. These directly address the biggest technical and financial hurdles for building sophisticated agents, and they're doing it with architectural cleverness, not just brute force context size.
Okay, let's look at context editing first. You mentioned the efficiency stats were phenomenal.
They really are. Context editing works by dynamically and automatically pruning the agent's active context window as the conversation progresses.
How does it decide what to cut?
It analyzes the history, the conversation, the tool calls the agent made, the results it got back. It then identifies and removes stuff that's become outdated or irrelevant to the current step of the task. Think old API call results, conversational tangents that are no longer active. It keeps only the bits deemed highly relevant for what the agent needs to do right now.
And the impact of this automatic pruning.
The results, especially for anyone running agents at scale, are staggering. In Anthropic's internal tests, they found context editing alone improved overall agent performance on tasks by 29%. Why? Because the model wasn't getting confused or sidetracked by irrelevant historical data in its context.
Okay, better performance is great. What about the cost?
This is the big one. That same context editing reduced token consumption by up to 84%.
84%.
84% reduction in tokens used. That translates directly into a massive potential cost saving for high-volume users. It effectively drives down the real cost of using their high-context models like Sonnet 4.5, making them much more economically viable for complex tasks.
That's a huge competitive advantage, especially against something like GPT-5 Pro with its high fixed cost. Okay, so context editing handles the short-term relevance and cost. What about the long-term memory problem? Agents forgetting project details between sessions.
That's where the memory tool comes in. This is the other crucial piece. It allows the agent to explicitly store important information project state, key insights it's learned, accumulated knowledge about the user's goals outside of the main context window.
How does it store it? Where does it go?
It functions like a dedicated long-term memory bank for the agent. It works by creating, reading, and updating files in a special client-side memory directory associated with the project or task. So the agent can say, save this finding to my memory file, or load the project requirements from memory.
So it can genuinely remember things across sessions, even if the application restarts.
Yes, that's the breakthrough. It finally allows for persistent, complex, iterative agentic development where the agent builds knowledge over time. We might finally be breaking that frustrating cycle of agentic amnesia, where the agent starts fresh every single time.
Okay, the combination of dynamic context editing and persistent external memory. That must fundamentally change what kinds of tasks these Claude agents can handle.
It seems so. Anthropic reported that the combined performance gain from using both context editing and the memory tool together was a 39% increase on complex multi-step tasks. This suggests they're enabling agents capable of much longer-term planning, more sophisticated iteration, and genuine learning within a project scope. It's a potentially significant leap beyond agents that just rely on ever larger context windows.
Really interesting architectural approach to the agent problem. Shifting gears slightly, but related to agents doing things, we're seeing the emergence of actual financial infrastructure built for them. Tell us about the Agentic Commerce Protocol, ACPAP2.
Yes, this is moving fast and it's significant. We're seeing the rapid development of payment protocols designed specifically for autonomous AI agents to use. OpenAI's ACP seems to be leading the pack currently.
Have there been actual uses?
Early days, but yes. There were successful demonstrations reported where agents running inside ChatGPT actually initiated and completed purchases on Etsy using the ACP protocol to handle the transaction securely.
Wow, agents buying things online.
Exactly. And Google wasn't far behind. They quickly announced their own similar protocol, the Agent Payments Protocol, or AP2. What this signifies is a rapid move towards a future where AI agents are treated as trusted, authenticated digital actors, capable of not just providing information or suggestions, but autonomously conducting transactions on behalf of users.
That has huge implications. Okay, back to the developer tools landscape. It feels like a war is brewing. Intense competition and competitive tooling between the big platforms and even the IDEs themselves.
It's definitely heating up. Google, for instance, launched Gemini Enterprise. This is pitched as a new, comprehensive business platform designed specifically to automate complex AI pipelines within organizations.
So a direct competitor to OpenAI's Agent Builder and also those existing workflow platforms like Diffy or N8N.
Exactly. It's Google's play to own that enterprise AI automation space with an end-to-end solution. Pricing starts around $21 per user per month, signaling they're serious about capturing that market.
And they also beefed up their command line tools, making workflows more modular.
They did. With Gemini CLI extensions, developers can now use simple JSON configuration files to essentially bundle together multiple different components, MCP servers for different tools, context files, specific instructions into a single reusable custom command.
Making complex agent setups easier to manage and share.
Precisely. It's all about making agent workflows composable, reusable, and importantly, shareable. Google even launched a dedicated marketplace for developers to share and discover these CLI extension configurations, fostering an ecosystem.
And Anthropic is doing something similar within their coding environment.
Mirroring that trend, yes. Claude Code added support for Anthropic plugins. These are defined using simple markdown files that describe the workflow, incorporating hooks for events, their version of MCP for tool communication, and / commands for invocation.
And these are shareable too.
Also shareable via a marketplace. It's a direct competitive response. Everyone is realizing that building a strong ecosystem around composable, shareable agent logic is key to winning developer loyalty.
But maybe the most intense battle is happening right inside the IDEs. Cursor, the AI-first IDE, seems to be adding features at an incredible rate. Version 1.7 sounded packed. Is it trying to become an agent OS itself?
That's exactly the feeling. Cursor is aggressively blurring the lines between a traditional IDE and a dedicated agent workflow manager. The updates to 1.7 are really significant for how developers might work with AI.
What were the key features?
Okay, first, browser controls. This allows the agent within Cursor to directly interact with your web browser, navigate pages, fill forms, potentially scrape data, and get live feedback on UI elements during web development or testing. A major step towards agents that can interact with the wider digital world.
Okay, what else?
Second, plan mode. For longer, more complex tasks, this mode forces the agent to first generate a detailed, step-by-step execution plan. The developer can review and approve this plan before the agent starts running code. The idea is to reduce errors and make the agent's actions more predictable and verifiable.
That sounds useful for avoiding those weird AI tangents.
Exactly. Third, hooks. These allow developers to extend the agent's workflows using their own custom scripts, triggered by specific events happening in the IDE or the codebase. Think custom linting rules enforced by an agent or automatic documentation generation on commit.
And the fourth big one, something about terminals.
Yes, and this one is crucial for security and real-world usefulness. Sandbox terminals.
Sandboxed, meaning isolated.
Exactly. It allows the AI agent to execute terminal commands like installing dependencies with pip or npm, running build scripts, executing tests, but within a secure, isolated environment. This directly addresses the huge security concerns people have about letting powerful AI models run arbitrary code on their local machines.
So the agent gets the power to interact with the system, but in a way that hopefully doesn't compromise the developer's machine.
That's the balance they're aiming for. Power, but with safety rails. Taken together, these cursor features really paint a picture of the future IDE. Not just a passive text editor, but a protected operating system designed for collaborating with AI agents.
That's a profound shift. Okay, this brings us to our final section, looking even further ahead. Part 4, New Frontiers in Intelligence, Robotics, and Infrastructure. Where is this all heading beyond just coding tools?
Where we're seeing fundamental shifts in how AI is being designed to understand and interact with the real world, or at least complex systems beyond just text. Take Meta's research on a code world model.
Code world model, what's different about that?
The innovation here is building a coding model that doesn't just predict the next token or line of code. Instead, it tries to understand code execution and the resulting system state.
So it's not just suggesting code, it knows what that code will do when it runs. It understands the consequences.
That's the core idea. An agent that understands the cause and effect relationship between code and system behavior. This could make it far more reliable for complex debugging, integration tasks, finding subtle bugs where the state changes the problem.
Interesting. Meanwhile, Google's pushing the boundary on agents interacting with our current digital world.
Yes, with Gemini 2.5 computer use. This model, built on 2.5 Pro and available via API, AI Studio, and Vertex AI, is being touted as the new state-of-the-art for agent-based interaction with a computer.
Controlling the OS, like clicking buttons, opening apps.
Exactly. Navigating the graphical user interface, controlling applications, manipulating files and windows, all with, reportedly, unparalleled proficiency for an AI. This kind of capability is a necessary stepping stone towards fully autonomous digital personal assistants that can actually perform complex tasks for us on our devices.
And shifting from the digital to the physical, NVIDIA made a big move in robotics, open sourcing key components.
A very strategic move. NVIDIA open-sourced its sophisticated Newton physics engine and also its foundational model for robot perception and action, GR00T and 1.6.
GR00T. What does that model do?
It focuses on spatial reasoning and planning for robots, understanding the environment, planning sequences of actions to achieve a goal. By open sourcing both the physics simulation engine and this core reasoning model, NVIDIA essentially created a complete, high-performance open-source toolkit for building and training robots.
What's the impact of that?
It massively lowers the barrier to entry for robotics startups, researchers, even hobbyists. You don't need to build your own complex physics simulation or your own foundational spatial reasoning model from scratch anymore. You can leverage NVIDIA's state-of-the-art work.
And they didn't develop this alone. There was collaboration.
That's also telling. The development, particularly the Newton engine, involved collaboration with Google DeepMind and even Disney Research. It shows these major players are willing to contribute core infrastructure back to the open community, likely hoping to accelerate the entire field by building on shared, high-quality foundations.
Okay, so the tools for building robots are getting better and more accessible. What about the robots themselves? Let's look at next-generation robotics. Humanoids seem to be making real progress.
They really are. Figure AI recently showed off their Figure 03 humanoid, and the specs are starting to look less like lab prototypes and more like potentially viable products.
What can it do? What are the key specs?
We're talking about a robot reportedly capable of handling fairly complex household chores, things like ironing clothes, doing laundry, general tidying up. It features autonomous recharging, so it can work for extended periods.
How long can it operate? How big is it?
Specs mentioned were 171 centimeters tall, about 5'7", weighs 61 kilograms, around 135 pounds, can lift objects up to 21 kilograms, 46 pounds. Crucially, it has a pretty robust 5-hour continuous operation time and can walk at a reasonable 1.2 meters per second, about 2.7 millipron.
Okay, those numbers, especially the 5-hour runtime and the lifting capacity, start to sound genuinely useful. That's enough time to complete meaningful tasks.
That's the key takeaway. It's moving beyond just impressive demos. And there's a pervasive rumor, again, just a rumor of a potential price point around $20,000 to $30,000, likely bundled, of course, with some kind of mandatory subscription for software updates, new skills, ongoing support.
$20,000 to $30,000, still expensive, but starting to approach the realm of, say, a high-end car, not purely science fiction anymore.
Exactly. It suggests we're rapidly moving towards actual commercial deployment, perhaps in niche markets initially. Humanoids are becoming a tangible economic possibility, not just a futuristic dream.
And Google's contributing to the brains of these robots, too.
Yes, with Gemini Robotics 1.5. This is described as an agent-based, two-model system specifically designed for more nuanced and reliable robot control.
Two models. How does that work?
It decouples perception and planning from low-level execution. One model analyzes the environment, takes in the operator's commands, which might be complex or ambiguous, figures out the high-level intent, and plans the required sequence of actions.
Okay, that's the thinking part. What does the second model do?
The second model takes that high-level plan and translates it into the precise, low-level motor commands and control signals needed to physically execute the action smoothly and accurately. This division of labor is thought to make the whole system more robust, less prone to errors from misunderstanding commands or misinterpreting the environment.
Makes sense. Okay, before we wrap up, a few quick but potentially impactful notes from foundational science and policy. These could shape the long-term future.
Right, couple of quick hits. First, a significant quantum leap reported out of Harvard University.
What did they achieve?
They managed to build and run a quantum computer continuously for over 2 hours without needing to stop, reset the qubits, or do complex recalibration. This addresses one of the biggest hurdles for practical quantum computing: qubit instability and short coherence times.
2 hours continuous operation. That's a big jump, isn't it?
It's huge. If this level of stability can be maintained and scaled, it suggests that the dream of quantum machines with effectively unlimited uptime might actually be achievable within, say, the next 2 to 3 years. That would unlock their potential for complex simulations and optimizations.
Wow. Okay, and another big science story, AI tackling fusion power.
Yes, researchers at MIT developed a sophisticated hybrid AI model combining physics-based simulation with machine learning specifically to predict and control plasma behavior inside fusion reactors.
Plasma instability is the big bottleneck for fusion, right?
It's always been the major challenge. Keeping that superheated plasma stable enough for long enough to get net energy gain. This AI model offers a potentially powerful new tool for understanding and managing that plasma, which could be a major step towards finally achieving stable, sustainable fusion power. A true game changer for clean energy if it pans out.
Absolutely. And finally, a policy note impacting the global developer pool. Something about visas.
A crucial note on global talent migration. China has introduced a new China K visa, specifically designed to attract top global STEM professionals.
What's notable about this K visa?
2 things mainly. First, it reportedly doesn't require a pre-existing job offer from a Chinese company. You just need a recognized STEM degree, making it potentially very accessible. This is seen as a strategic move to attract tech talent, perhaps those feeling priced out or frustrated by recent hikes in U.S. H-1B visa fees or increased regulatory hurdles there.
So, lowering the barrier to entry for STEM talent, what's the catch?
The catches are significant. Applicants apparently need to demonstrate proficiency in Mandarin Chinese. And critically, there's a non-naturalization requirement attached. They want the talent, the skills, but they seem keen on preserving national identity pathways. It really underscores this intensifying global competition for the best minds in AI and STEM fields.
Fascinating. Okay, wrapping it all up. This week really felt like a showcase of this fierce battle for developer adoption, for developer mindshare.
Absolutely.
It seems crystal clear now that winning isn't just about having the absolute most powerful model or being able to slap an astonishing price tag on something like GPT-5 Pro. The real competitive edge seems to be shifting, doesn't it? Towards that clever architectural efficiency like we saw with MoE, or that incredible tiny recursive model, and towards really sophisticated, tightly integrated developer tools like Anthropic's context editing or Cursor's sandbox terminals.
That's spot on. And what's really fascinating, I think, is how the introduction of these powerful developer SDKs, the visual agent builders, these deeply integrated IDE plugins, all these things designed to turn models into persistent, authenticated, even transaction-capable agents. It raises a really core, maybe even existential question for you, the developer listening right now.
Which is?
Are we actually witnessing the slow, maybe inevitable death of the traditional IDE as we've known it? Is it being gradually replaced, maybe entirely, by these new kinds of agent operating systems built around the foundation models themselves? That structural shift, that potential platform transition.
Yeah.
That's what we really need to be watching closely right now.
A very compelling question to chew on as you head back to your code editor this week, whatever form it takes. Definitely food for thought. Okay, that wraps up our deep dive. Just a reminder, all the links to the news items and research papers we discussed today are provided in the text version accompanying this session. Thank you for joining us for AI DevHub Digest.